All right, today we're going to go on a bit of an architectural tour, but we're not looking at a building. We're looking at one of the most incredible structures right inside your own body, the abdominal wall. Seriously, think of it as this living, breathing barrier, one that's engineered to be both super flexible and incredibly strong. But, like any great structure, it has a story of stress, strain, and yeah, sometimes some pretty spectacular failure.
So let me ask you a question. When you lift something heavy, or you cough really hard, or you even just stand up, what is actually stopping your insides from, well, becoming your outsides? What is that barrier holding everything in place? The answer is way more complex and, frankly, way more fascinating than you probably think. You see, it's not just some simple sheet of muscle. Nope. It's this sophisticated, multi-layered system designed for both containment and for movement. And understanding its design, its architecture, is the absolute key to understanding why it sometimes fails. So come on, let's grab our blueprints and start the inspection.
Okay, first things first, let's look at the blueprint. I mean, to understand how a wall can fail, you've got to know what it's made of, right? We're going to peel back the layers one by one from the outside all the way in, just to see how this thing is actually built. So our wall is built in 6 totally distinct layers. It starts with the skin and goes all the way down to that innermost lining. You can see them all right here. But the real star of our show, the one we really need to zoom in on, is layer number 4, the transversalis fascia. This is it. This is our primary structural barrier.
So here's the crucial point. If your abdominal wall is a house, the transversalis fascia is the most important sheet of drywall in it. It's this thin but really tough membrane that provides the main resistance against all that internal pressure. When this layer gets weak, you get a bulge, you get a hernia. It is, without a doubt, the single most important structure in this entire story.
Now, of course, that drywall doesn't just stand there on its own. It's reinforced by this incredibly clever muscular support grid. And this isn't just one big slab of muscle. It's a series of layers, with fibers running in all different directions, which creates some amazing strength. And here is the genius part of the design. The muscle fibers don't all run the same way. The external oblique fibers, they run downwards, kind of like when you put your hands in your pockets. But then the internal oblique fibers run perpendicular to that, upwards and inwards. And finally, the transversus abdominis runs horizontally. This crisscrossing pattern, it's like biological plywood. It creates this immense strength in literally every direction. So clever. But even the best designed walls can have weak spots. Our bodies are the product of evolution, not some perfect engineering blueprint. And built right into this abdominal wall are a few inherent areas of weakness. Let's just call them design flaws. And this is where our little architectural inspection turns into a full-blown detective story. The first major weak spot is something called the inguinal canal. Just think of it like a utility tunnel that absolutely has to pass through the wall. In males, it lets the spermatic cord pass from the abdomen down to the scrotum. It's a totally necessary passage. But let's be real, punching a hole through your main support wall is always going to create a structural risk. Okay, so now let's zoom in a little closer. Within this already risky area, there's a specific zone of maximum weakness. It's called Hesselbach's triangle. This is the exact spot where our critical inner drywall, that transversalis fascia, is at its absolute thinnest. It's just a natural weak point, kind of waiting for something to give.
So what defines this weak little triangle? Well, it's bordered by muscles and, crucially, by these blood vessels, the inferior epigastrics. Now, for a surgeon, these vessels are like a surveyor's line drawn right on a map. They are a perfect landmark that tells them exactly what kind of failure they're looking at.
So we have the layers, we've got the support grid, and we've got the built-in weak spots. Now, what happens when you add years and years of pressure, from lifting, from coughing, from just plain straining? Well, the wall can fail. Let's take a look at exactly how that happens. Now, hernias in this region, they generally come in 2 flavors. First, you have the indirect hernia. This is basically a congenital issue, a kind of birth defect. A natural passage that was supposed to close up after birth just stays a little bit open, letting things slip through. And then there's the direct hernia. This is more of a wear and tear problem. It's what happens when that thin drywall and Hesselbach's triangle just gets weaker over the decades and finally gives way. So, how do you fix it? Well, for years, the approach was pretty simple. Find the hole, patch the hole. But surgeons started noticing that something wasn't quite right. And then a single brilliant insight came along that would completely change how we think about repairing this wall.
And here it is, the big aha moment. Surgeons realized they weren't dealing with a bunch of separate, unrelated problems. Direct hernias, indirect hernias, they were all just different symptoms of the exact same root cause. One single large zone of structural weakness.
And this insight gave that whole at-risk zone a new name, the myopectineal orifice. This concept, which came from a surgeon named Fruchoud, it unified everything. The new thinking was suddenly so clear. Stop patching individual cracks. The entire foundation is compromised.
And this just completely revolutionized the surgery. I mean, why would you patch a small crack in the drywall when you know the whole sheet is faulty? Modern laparoscopic repair doesn't just stitch up one tiny hole anymore. It goes in and places a large sheet of synthetic mesh over the entire myopectineal orifice, reinforcing the whole weak zone all at once.
Okay, so let's put all the pieces together. What have we learned? Well, we know all these hernias are really a failure of that deep inner wall. We know a direct hernia is from wear and tear, while an indirect one is a leftover issue from birth. And most importantly, we now know that a real, lasting repair has to reinforce that entire weak zone, the myopectineal orifice.
And this quote just perfectly captures the whole mindset. Hernia surgery is applied anatomy. It's all about asking these three simple but really profound questions. Where did the engineering fail? What specific part broke? And what's the absolute best way to reinforce the entire structure so it never fails again?
So it leaves us with this really fascinating thought, doesn't it? This design flaw isn't really a mistake. It's like a fossil record of our evolutionary journey. It reminds us that our bodies are an incredible, complex compromise, and it shows that modern medicine, when it's at its best, isn't just about fixing problems. It's about understanding and then intelligently reinforcing the beautiful imperfections of our own biology.